In this video, we have the integral of 1 over 3 times radical x plus 1. And I want to remind you of this formula before we start the procedure for the given one here. Anytime you have an integral of the form k over ax plus b, have a first degree binomial here, the answer will always be the natural log of whatever you have in the denominator, and then whatever a is, that divides the k. If this is just a 1, of course you have 1 over a. I derived this formula in another video and I've used it in several videos. So I'm going to use a U-substitution for this one. There's some problems where you let u equal to the whole denominator. In some cases just a radical expression. Here I'm going to let u equal to the square root of x. And then I'm going to try to transform this and go into one involving the variable u and see if we can make it easier to integrate. So I'll let u equal to the square root of x. I'm going to square both sides here. Sometimes you can get away without doing this, but sometimes it makes it easier. I square both sides and I get this. Then I take the derivative of both sides with respect to u on the left. I get 2u du. Derivative of x will be 1, so this will just be dx. Then I make my substitution here. In the numerator I'll have the dx. 1 times dx is dx. And that'll be replaced by 2u du. In the denominator I'll have 3e square root of x. Square root of x is the u. So I get 3u plus 1. Now this is a rational expression in the variable u, but it's not in simplified form. So we want to reduce this by dividing in this case. We want the degree of the numerator less than the degree of the denominator. Now it's 1 and 1. So let's just divide here. Long division. 2u divided by 3u plus 1. So 3u into 2u will go. The u's cancel out. I get 2/3 here. Then I multiply the divisor by 2/3. So 2/3 times 3 will give me 2u, and 2/3 times 1 is 2/3. And then we subtract here. 2u minus 2u cancels, and here's 0 here. 0 minus 2/3 is a minus 2/3. Since the degree of the remainder is less than the degree of the divisor, we can stop right there. And we can go ahead and just say that this is equal to, we're just going to replace a rational expression, this right here, 2u over 3u plus 1 by what we get. Quotient here is 2/3, so we put 2/3 here, plus, and then it's the remainder, which is a negative 2/3, divided by the divisor, which is 3u plus 1. We can write this as two integrals, but we just do it this way. Just do it, say, integral of 2/3 with respect to u. That's just going to be 2/3 u. And this is when I'm going to use the formula that I just went over at the beginning of the video. See, I have a linear factor there. So according to what we had, this is just going to be the natural log of the absolute value of this right here. It's going to be absolute value of 3u plus 1. We're going to have a constant of integration here. And this right here, that's going to be your k in the formula that I just went over at the beginning of the video. And then this is your a right here, 3. So the minus 2/3 gets divided by 3 and really multiplies, so this is going to be minus 2/9. And that's the integration with respect to u. But remember, in these, you always go back to the original variable. So the original variable is an x, so u is equal to the square root of x. So this is going to be 2/3 u, and u is the square root of x. And it's minus 2/9. And this is ln. And this is going to be 3. U is the square root of x. There's plus 1 here. Now because the square root of x is always a positive value, okay, so it's to be the positive root, and this times the positive 3. So 3 square root of x plus 1 is always positive. I don't need the absolute values here, so I just put parentheses. And it's plus the constant of integration. That's your answer. 2/3 square root of x minus 2/9 ln of 3 square root of x plus 1 plus the constant of integration. Thanks for watching. We'll see you next time.